What if we lived at the center of the galaxy? If you have even a rough idea of the conditions there, you've probably already answered this question. We wouldn't live there, because life would be impossible. But is that really the case? In the movie Interstellar, weren't there planets suitable for life orbiting a supermassive black hole? But a work of fiction, even if one of its authors is a Nobel laureate in physics, isn't exactly a strong argument. On one hand, it's not just the possibility of life that's in question here, but the very existence of planets in the center of the galaxy. And this question is currently being actively studied. On the other hand, we should clarify what we actually mean by the central region of the galaxy. Are planets and life possible where exactly? In the galactic bulge? In the group of stars that are closest to the center? In the immediate vicinity of the central black hole? Here, there's actually a lot of interesting stuff we can talk about. Do planets exist at the centers of galaxies? How could they form there? And what might prevent it? Which planets closest to the galactic center are already known? Is life possible there, and what would it be like to live not on the outskirts of the galaxy, as we do now, but right at its center? We'll talk about all that and more today. I'm Andre, and this is Cosmos Elementary. The ingredients and conditions necessary for the emergence and possibility of life is a popular discussion. And also how it sometimes seems that so many things had to align, so many parameters and factors had to be exactly as they are on Earth, that it seems that the emergence of life on Earth is, if not unique, then extremely rare. Among the main factors, there are the distance of a planet from its star, the presence of water and an atmosphere on the planet, and others. But one thing that's especially hard to imagine life without is a planet. I mean, you have to live somewhere, right? Of course, you could imagine some hypothetical organisms that would live on stars. And by the way, such ideas have already been discussed. But it is somewhat easier to talk about and search for life, which is roughly similar to ours. And here, having a planet would certainly help. So what about planets in the center of our galaxy? In general, this question is quite multi-layered, especially if we're interested in potentially habitable conditions. And here we can distinguish several levels. First of all, are there even any planets there at all? Second, if planets do exist, can they remain stable in their systems for long periods, given the chaotic conditions, especially in certain regions? And finally, if a planet exists and is stable, could it have conditions suitable for life, at least in some form? Let's start simply with the presence of planets. And even here, things aren't that straightforward. What's the problem? Not so long ago, we could only guess that planets probably exist everywhere, but we had no proof. Until about 30 years ago, when scientists began discovering exoplanets, so the situation now is quite different. You may have heard that today it is believed that our galaxy could have 1 trillion planets, and that every star has at least one planet. If that's the case, then the question is settled. But I've overlooked one important clarification. On average, every star has at least one planet. That doesn't mean that all stars have planets. But still, there are stars even in the immediate vicinity of the supermassive black hole at the center of the galaxy. The question is how they ended up there. Whether they formed right in that region or got there some other way, which we'll talk about later. But what I'm getting at is that planet formation is closely intertwined with star formation. When a star forms, the leftover material creates a protoplanetary disk around it, where planets then begin to take shape. And since there are stars there, and they somehow managed to form, why couldn't planets form as well? But with planets in the center of the galaxy, there are both theoretical and practical problems. As for the theories, it seems that what we know about the conditions in the galactic center isn't very encouraging. The tidal forces from the black hole, possible galactic winds, the extremely dense population of stars packed close together and moving at tremendous velocities, and other factors could either prevent planets from existing stably or from forming at all. From a practical point of view, well, we are discovering exoplanets. We just need to find planets there and we'll have a concrete answer. But the galactic center isn't exactly close. It's about 26,000 light-years away, and most of the exoplanets discovered so far are located within a relatively small region surrounding the solar system. Although direct searches for planets there are underway and have already yielded some results. Scientists are also using some interesting indirect methods that could point to the presence of planets in the center of the Milky Way. Another question is how broadly we define the galactic center. As I already mentioned, it's one thing to talk about the galactic bulge, the thicker central region of the galaxy. It's not small by any means, and the conditions there are different from our region of the galaxy, but still, stars can exist there and be quite far from the central black hole. Closer to the black hole, there are groups of stars orbiting directly around it. Could these stars have planets? And finally, scientists also consider whether planets could exist around the black hole itself, that is, orbiting it independently without any stars, with the supermassive black hole taking the place of a star, kind of like in Interstellar. These kinds of planets even have their own name, Blanets. It's a combination of a black hole and planet. In short, there are many questions, so let's see what answers we can find here. For a star to form and then planets around it, certain conditions are required. The cloud of material must be dense and cold. A fragment of the cloud can collapse under the influence of gravity, but whether this happens depends on its temperature. If the temperature of the material in the cloud is too high, the particles in it move too fast. Just as planets don't fall into the sun because they move at a certain velocity, their motion prevents the sun's gravity from pulling them in completely. The same goes for particles in clouds. If they move too fast, the cloud won't collapse and stars and eventually planets won't form. That's why stars and planetary systems don't form just anywhere but in molecular clouds of gas and dust. The temperature there is only slightly above absolute zero, around 10 Kelvin or minus 263 degrees Celsius or minus 441 Fahrenheit. And if we think specifically about the very center of the galaxy, especially when looking at animations of supermassive black holes, what we see there doesn't really resemble cold clouds. But in fact, these animations show quasars, more precisely active galactic nuclei. They consume enormous amounts of material which gets so heated and emits so much radiation that it can significantly affect the evolution of the entire galaxy. But as we know, this is more characteristic of the early universe, and the black hole at the center of our galaxy isn't considered active. Sure, there are some occasional small bursts of activity, and it does accrete some material, but these processes are orders of magnitude weaker than in active galaxies. But besides radiation, the black hole exerts tidal forces, which prevents stars and planets from forming by disrupting molecular clouds that get too close to it. And yet we know that there are stars very close to the black hole. In fact, studying these stars and their motions around a massive object served as one of the main pieces of evidence for its existence and allowed astronomers to calculate its mass. I'm of course talking about the cluster of so-called S stars, which orbit the black hole. The letter S in the cluster's name comes from the central object Sagittarius A star, or essentially the black hole itself. One of the closest, the S2 star, approaches the black hole at its closest point to just 120 astronomical units. Both Voyager spacecrafts flew away farther from the Sun than that. In short, stars somehow managed to appear even that close to the black hole, though exactly how remains uncertain. Either there are mechanisms that allow them to form right there, or they form farther out, in calmer conditions, and later get captured by the black hole. We don't know which yet, but the fact remains, stars are there. Yet, we are not sure about planets. But for now, let's zoom out a bit from the black hole, we'll come back to it later. The way and type of planets that can form around stars also depend on the stars themselves and the configuration of their systems. For simplicity, let's focus on single stars for now, even though they may be a minority. How do stars differ from one another? Primarily in mass, which in turn determines their lifespan and luminosity, factors that can be important for planet formation and for life. They also differ in chemical composition. We are particularly interested in a parameter called metallicity, which measures how much stuff consisting from elements heavier than hydrogen and helium is present in a star. But what does it tell us? If we look at the planets astronomers have already discovered and analyze whether the presence of planets depends on the chemical composition of their stars, we see that such a dependence does exist. Stars with low metallicity have noticeably fewer planets, especially rocky, Earth-like planets, the ones we're most interested in. And if you think about it, that's not surprising. Why do some stars have low metallicity? Well, because they're old. Generally, the more chemically primitive a star is, the older it is. After all, as we remember, the early universe consisted mostly of hydrogen and helium, along with a couple more isotopes. Heavier elements, including those that make up rocky planets, appeared later in the cores of stars and through other star-related processes. Consequently, if a star is old enough and its content of elements heavier than hydrogen and helium is below a certain level, many types of planets simply won't have the material to form from, especially Earth-like planets which are primarily made of these heavier elements. Planets can still exist around such stars, but they are more likely to be gas giants located far from the star, which can form through processes other than accretion. It's more similar to how stars themselves form, described by the disk instability model. What does all this tell us? And in the center of the galaxy, there is a thicker region called the Bulge, and it consists mostly of old stars with low metallicity, which on average have a lower chance of hosting planets, especially Earth-like ones. Plus, the stellar density is higher there, meaning many more stars occupy the same volume of space, which may also be unfavorable for the stability of planetary systems. Frequent close encounters with other stars can destabilize planets in their orbits, either ejecting them from their system or even sending them into the star. Another extreme example is very massive stars, hot blue B-type stars, and especially O-type stars. The problem with those stars is different. They are extremely luminous, and their radiation and stellar winds can blow away the remaining material in the protoplanetary disk, preventing planets from forming. That's the first issue. Secondly, their lifespans are extremely short, tens of millions of years at most, compared to billions of years for less massive stars. A planet could certainly form in that time if there's enough material, but whether life could arise before the star explodes as a supernova, that's a big question. On top of that, finding planets around such stars is very difficult because they are so bright. In general, we know almost nothing about planets orbiting these stars. Meanwhile, even in the immediate vicinity of the black hole, there are quite a few of these stars. Within less than a light year from the central black hole, there is a disk containing hundreds of young O-type stars. Even closer is the S-star cluster, which isn't a disk, but the stars there follow randomly oriented orbits. And these stars are less massive. So it seems that, in addition to a rather unusual environment, the stars themselves add complications for planets. It's worth remembering, though, that the stars we see there are massive ones, which are less likely to form planets simply because they are so bright. And usually, the more massive a star is, the rarer it is. So there could easily be many more or less massive stars that we simply don't see yet because they are too dim. For them, having planets should be somewhat easier. So it seems that, in addition to a rather unusual environment, the stars themselves add complications for planets. The idea here is that a disk of material around a supermassive black hole can, in a way, resemble a protoplanetary disk around a young star, only much larger. It could be large enough that, at a certain distance, the conditions aren't so extreme, tidal forces are weaker, the temperature is lower, and planets could potentially form there. There have even been several studies in which scientists modeled this scenario, and they concluded that, under certain conditions, planet could indeed form. A single black hole could have thousands of planets, including both gas giants and rocky super-Earths. and this is exactly reminiscent of the scenario in the movie Interstellar. So far, we've only discussed things theoretically, looking at factors that could affect the presence of planets. But what about actual observations? Have any planets really been found in the center of the galaxy? If you check various exoplanet resources, it seems that it's not easy to quickly pick out from thousands of planets those that are located close to the center of the Milky Way. For example, here's a cool time-lapse made some time ago to celebrate the discovery of 5,000 exoplanets, showing a panoramic view of the sky and where the stars are located. Most exoplanets discovered so far have been found using the Kepler telescope, which did not look in the direction of the galactic center. Here's its field of view. But fortunately, Kepler is not the only telescope that has discovered exoplanets. Here we can also see those concentrated near the galactic center. The problem is that this map shows where the planets appear in the sky, but it doesn't indicate distances. They might just visually align with the galactic center while actually being much closer to us. That means you also need to determine the distance and compare it with the star's position in the sky. That information we could find at various exoplanet catalogs. We can sort by distance, and here we find the most distant planet with a known distance here from us is SWIPS 4b. It's 27,727 light-years away, making it one of the farthest planets discovered to date. And that distance is quite close to roughly 26,000 light-years to the galactic center. But this planet could be in a completely different direction. Here it doesn't even say which constellation it's in. Fortunately, the information we need is already in the planet's name. SWIPS is the name of an observational program carried out using the Hubble Space Telescope. The name stands for Sagittarius Window Eclipsing Extrasolar Planet Search, a search for exoplanets in Sagittarius. And the center of the galaxy is located in the direction of constellation of Sagittarius. Here, the area where the observations were conducted is marked with a green square, and it's quite close to the galactic center. Now, taking into account the distance and the region in the sky, we can conclude that this planet is in the central area of the galaxy, though not in immediate proximity to the black hole. Still, the very existence of planets here had been in question. It's a shame that this planet is a gas giant with a mass of 3.8 times that of Jupiter, rather than an Earth-like planet. But it's not the only one. I also found this map, though unfortunately it's not interactive. It clearly shows in orange where most of the known exoplanets are located. Additionally, a few exoplanets discovered not by transit method, like most, but by microlensing, are marked with yellow dots on the map. When a closer star passes in front of a more distant star, and it aligns along our line of sight between the observer and the distant star, the closer star can act as a gravitational lens and temporarily amplify the light of the background star. If this intermediate star also has planets, they can produce a similar but weaker effect, which shows up in the light curve of the distant star. And as we can see, there are also planets very close to the galactic center. One of these planets is named OGLE 2005 BLG 390LB. It's not as massive as the previous one, only 5.5 Earth masses. The catalog describes it as Neptune-like, but its mass actually falls within the super-Earth range. There have been suggestions that it might be rocky. The conditions, however, are most likely unsuitable for life. Its distance is listed as 21,500 light-years, but there is a fairly large margin of error in that measurement. In short, despite the concerns and arguments I mentioned earlier, planets do exist fairly close to the center of the galaxy. And we need to keep in mind that most of the planets we discover are relatively close to us, simply because they are easier to detect. You've already seen the map showing Kepler's observation field. There have been studies that approach the question statistically. The authors concluded that, although conditions in the Bulge are different and the number of planets in the central region may vary, there should still be quite a few planets there. The examples I've given, although in the center, are apparently not in the immediate vicinity of the black hole. So what happens to planets in the very heart of the galaxy? Here we have three main possible scenarios. Potential planets could exist around stars in the disk located more than 0.1 light-years from the black hole, in the group of S stars, which is closer than 0.1 light-years, or as rogue planets orbiting the black hole itself. So far, we haven't reliably detected planets in any of these scenarios, but the fact that they can exist there is supported by two sources. First, scientific computer simulations, and second, observations that may indirectly indicate the presence of planets. As for simulations, we have, for example, a study called Stability of Planetary Systems within the S-star cluster, the Solar System Analogs. This is exactly what the authors of the paper tested using simulations. It is expected that the proximity of the supermassive black hole, as well as constant close encounters with other stars, will destabilize the systems. And it's probably no surprise to anyone that, yes, they do get destabilized. But what might be surprising is that, in this case, simulations showed that it doesn't happen all the time. In 51% of cases, the planet survived, meaning they remained with their stars for a long time and were not ejected from their systems. The planets that most often survived were those located close to their stars, analogs of Mercury in older systems. And in younger systems, Jupiter analogs were more likely to survive. What about Earth-like planets? In young systems, they survived in almost 17% of cases. The chances aren't very high, of course, but not zero either. And depending on the number of stars, several Earth analogs could quite possibly exist stably in orbit around stars near the black hole. In rare cases, planetary systems swap planets. That is, after a planet is ejected from its system, it doesn't just drift alone, it can be captured by another star. But what's also interesting is that 49% of the planets that don't remain within their stars aren't destroyed. Instead, they end up in orbit around the supermassive black hole. These orbits are similar to those of the S stars and are randomly oriented. So, at the very least, this study shows that if planets form in the very center of the galaxy or end up there along with their stars, it's not necessarily the end for them. They can quite possibly continue to exist there for a long time, even Earth analogs. Though analogs here most likely means similar in general properties like mass or size, rather than in environmental conditions. And this is not the only study of this kind. In this paper, the authors simulated not only planets around stars in the S cluster, but also in the stellar disk located slightly farther out. Overall, the conclusions here are that being in the very center of the galaxy does not necessarily mean the planet's demise. They can remain in their systems around stars, or they might be ejected from their systems but continue to exist. Planets around stars in the disk continue to move along similar orbits, which are not very elongated, whereas in the S-star cluster, the orbits are more stretched out. In short, although it might intuitively seem that the proximity to a supermassive black hole spells the end for a planet, this is by no means necessarily the case. But interestingly, the existence of planets can be indirectly confirmed by their death, their destruction near the black hole. This is discussed in this scientific paper. As I mentioned before, our supermassive black hole is considered inactive, but it still does accrete some matter. Sometimes it can even destroy a star similar to the Sun, though this happens quite rarely. According to the scientists' estimates, about once every 10,000 years. Such an event would noticeably increase the activity and brightness of the galactic nucleus, but so far we haven't observed anything like that. However, we do observe short, weak flares in the region around the black hole, and they occur almost every day. What causes these flares? The authors of the paper propose the following explanation. Around black hole, in addition to stars, there may be also a population of small bodies such as asteroids. It was named the Super Oort cloud, by analogy with the cloud of icy bodies that likely surrounds the solar system, and likely other systems as well. These daily flares may be caused by a black hole destroying asteroids. To account for such flares, the asteroids would need to be more than 10 kilometers across. And so, where there are smaller bodies, there may also be larger ones. planet-sized bodies would simply occur much more rarely. Perhaps if a brighter flare were to happen than the ones we observe now, that would indicate the destruction of a planet, and it would serve as indirect evidence that the planets exist around the black hole. Unfortunately, such events have not been observed recently. But there was one interesting case about 300 years ago: a presumed flare and an increase in the luminosity of a supermassive black hole. You're probably puzzled. Who could have observed a flare near the black hole 300 years ago? Well, of course, no one actually witnessed the flare itself. A light echo was observed, reflected from a cloud located 300 light-years away from the center. And the authors of the paper write that this flare may be explained by the destruction of a planet by a black hole. But one interesting event that happened more recently is connected with the well-known G2 cloud. Some time ago, an object was discovered at the center of the galaxy, something that looked like a cloud. There were several hypotheses about what this object might be: a cloud of gas, a low-mass faint star shrouded in a dust cloud, a star destroyed by another stellar mass black hole, the product of two stars merging, or a star partially torn apart by a supermassive black hole. But the version that particularly interests us, as described in this paper, states that the object might have been a low-mass star with a protoplanetary disk. This star may have originated from the nearby stellar disk. And if so, that would prove that even stars so close to the black hole could possess protoplanetary disks and are capable of forming planets. The object was moving quite rapidly, and calculations showed that in 2014 it was expected to make its closest approach to the black hole at the center of the galaxy. Simulations showed that if it were merely a cloud, it would not survive the close encounter and would be torn apart by tidal forces, as illustrated in this simulation. 2014 was quite some time ago, and now it's not just simulations, we have real observations, and they show that the object survived the close encounter. So it's possible that this isn't just a cloud, but something more substantial. Could it be a faint star with a protoplanetary disk? There have already been studies conducted after the close encounter, in which researchers considered the scenario that the G2 cloud might have been a planetary embryo. And, by the way, more than one such cloud is now known. So for now, we know for certain that planets do exist in the central region of the galaxy. But in the case of the region in the immediate vicinity of the black hole, we don't know for certain. Though there are some theoretical grounds and indirect observational data for it. But let's suppose there are planets there after all. Could life exist on them? Here we can recall the concept of the galactic habitable zone. Just as in planetary systems, scientists define a certain region where liquid water could exist on a planet's surface, making life as we know it possible. They discuss a similar idea, but on the scale of entire galaxies. And in fact, the galactic center, even in our inactive galaxy, is usually not included in this zone. Many reasons for that I have already mentioned today. Even for life to exist on our planet in a relatively calm region of the galaxy, that calmness alone is not enough. Many other factors are required. Remember one of the main obstacles to space travel: cosmic radiation. It is dangerous within the solar system where the sun is the main source. But besides that, the sun also protects us from the galactic radiation. If we were in interstellar space without special shielding, the impact of galactic cosmic rays would not be pleasant. Now imagine an environment with tens or even hundreds of times more stars within the same volume of space. Protection against such radiation would have to be far stronger than what our planet currently has. Moreover, the closer proximity of stars, especially young ones, carries the threat of more frequent nearby supernovae, which could have catastrophic effects. Our solar system is likely surrounded by the Oort cloud of icy bodies, and comets may come from there into the inner solar system when other stars approach the cloud, destabilize their orbits, and send comets closer to the Sun and Earth. If the stars are closer and more numerous, this could happen much more often, leading to more frequent impacts of large asteroids and comets on the planet. Therefore, it is believed that we are fortunate to be located far from the galactic center and outside the spiral arms, where there is more gas and where new stars form more frequently, which can explode as supernovae. All this so far suggests that it's much harder to imagine not only the existence of complex life, but even its very emergence on a planet in the center of the galaxy. Of course, this doesn't mean that it can't exist there in principle. And I'm not even talking about some fundamentally different form of life that we don't understand, which would require completely different conditions and components. Yet, we can't fully rule it out either. At the very least, one can imagine, for example, a system around a star, near a black hole. Suppose the system has giant planets that deflect some of the comets and asteroids, while protection from radiation is provided, for instance, by a thick icy crust. Yes, I'm speaking of hypothetical life, not on the surface, but in oceans, on bodies analogous to Europa and Enceladus. At least some of the threats could be mitigated by certain conditions. Although, if you're suddenly thinking about moving to another part of the galaxy, heading straight for the very center probably isn't the best idea. It is better to choose a region similar to ours, even if the starry sky there promises to be incredibly beautiful, with a vast number of bright and perhaps even the black hole itself visible in the sky. There have also been studies in which scientists considered the scenario of the possibility of life existing on a planet orbiting directly around a black hole at the center of the galaxy, just like in Interstellar. And there are very interesting conclusions regarding the source of energy. After all, as we remember, water alone is not enough. Life also requires essential substances and, above all, energy. In our case, it is the sun. But where would one get energy from a black hole? Of course, it may be active and shine brighter than billions of stars, but in that case, life is certainly out of question. But if the black hole is inactive, the conditions might be milder. Yet, where would one get light and energy for life? And this is precisely where an interesting idea arises. The authors of this article, titled "Life Under a Black Sun," and later of another more recent paper, suggested that the black hole, which strongly warps space-time with its gravity, could capture photons of CMB relic radiation and pull them from the microwave part of the spectrum back into the visible range, thus producing light as bright as that of a star. Sounds really cool. The truth is that for a planet to receive enough light in this way, its orbit would have to be very close to the event horizon of the black hole. Under certain conditions, stable orbits there are possible. In supermassive black holes, tidal forces are not the same as in compact stellar ones. It's even possible to cross the event horizon of a supermassive black hole without being torn apart into particles, unlike in the case of a stellar black hole. But in that case, the mass of such a black hole would have to be 163 million solar masses. And that means our black hole with its mere 4 million is not suitable for this. Although, of course, in any case, these scenarios are hypothetical, though very interesting. For now, much depends on our limited capabilities. There has been certain progress, and as we have found out, planets are already known not too far from the center. Yes, we can speculate and build theories, but in the future, with the deployment of more advanced telescopes, scientists may directly discover planets in the very central part of the galaxy. And this is not just idle curiosity. Such research helps us better understand the structure of galaxies, planetary systems, the formation of planets and stars, and what life in the universe may be capable of.